All right, so your icebreaker today was when you hear the word minerals, what do you think of? Does anybody have any thoughts? When you hear, when you hear the word mineral, good. Like jewelry? Oh, grains. Okay, grains. Yeah. Anybody else? Same thing.
Us,
What do you mean us?
the salt that we have in our bodies.
The what?
We have salt, human beings as a, people as a being have a mineral and it's salt, like we're mostly salt and water.
Right.
So, us.
Have you guys ever heard of mineral water? Like people will sell mineral water, and you can go to some pretty expensive places just to buy mineral supplements. So all of those things are minerals. Here we're going to talk about when we're going to talk about when a geologist says mineral, what he means by mineral. But all those are good examples of minerals. Like for example, mineral water. When we drink tap water and even bottled water, it's not pure H2O. And actually, pure H2O would not be good for our bodies because we need certain minerals and certain amounts of salt in our body to survive. And it'd be very tasteless. The reason why water tastes good is because it has something besides just water in it. We can't actually taste water. We're tasting the minerals and salt inside the water. So let's talk about minerals and what a geologist means by minerals. So these four characteristics are going to be very important to us. They're going to tell us like what makes a mineral a mineral. Before I go on and describe these, let me just say that a mineral, every rock that we've dealt with so far, every rock is made of minerals. You can kind of think about minerals as the building blocks of rocks. Like if you ever take a chemistry class, they'll tell you that everything is made up of atoms or molecules. Well, rocks are made of minerals. So what is a mineral? A mineral is naturally occurring. That means it's not man-made. Now you can make synthetic minerals, but the point of that first rule is that nobody can go to a lab and say, hey, I made a new mineral. It must first occur in nature first. Because we can make synthetic quartz, for example, but it must be found in nature to be called a mineral. It is inorganic, has a singular chemical composition, is a solid crystalline substance. So I'm going to talk about what each one of those things means. And then I'll kind of quiz you guys to see whether you can identify the difference between just a plain old rock or a mineral. Yeah, so minerals are the building blocks of rocks. Oh, this isn't showing. Sorry about that. We'll come back to these. We're actually going to go through each one. Okay, so like I said, all minerals are naturally occurring. So on the left side there, you see quartz in its natural form. On the right side, you see manufactured quartz. That quartz is what makes that nice, fancy marble countertop. It looks nice and shiny. Let me just go back a little bit for you guys. So synthetic quartz versus natural quartz. So the point is that we can make minerals in the lab or in a factory, but to call it a mineral must be first be found in nature. There's no such thing as a purely synthetic mineral. Inorganic. Let me just ask you guys, what do you think that word inorganic means? Like when you go to the grocery store and you see inorganic, when you see organic versus inorganic? Yes. Yes, something that's not natural. Any other? Doesn't have human, say that again? Doesn't have human help? When you go to the grocery store and you see organic fruit or organic vegetables, what does that mean? Do you know? Are they usually more expensive or less expensive? They're more expensive. Yeah, so basically when you go to the grocery store, those are organic produce. Like they say no pesticides and must be certain types of fertilizer. But whenever we say organic in science, organic just means that it is living or once was living. So as far as rocks are concerned, like for example, that leopard right there, it's organic because it's alive. those leaves on the ground, even though they're dead, they're organic because they were once living. On the right side, there's a couple examples of things that are inorganic. So most rocks are considered inorganic, not all rocks, but most rocks are inorganic. The sun is inorganic, again, because it's not alive. It never was alive. So minerals are made of inorganic material, meaning that they come from things that were not living, and they aren't living. Which kind of seems, let's go ahead.
Do you think the sun is not living?
So it's not living in the sense that it cannot reproduce.
Because if it dies out or it's fire, we need.
Yeah, we say that it's, yeah. So the sun helps us live, but it's not alive in the sense that it can't reproduce. It doesn't make decisions. I'm gonna close that door. So here's an example. So on the left we have diamond, and on the right we have coal. Diamond or coal both made of carbon. That's just the name of the element is carbon. But carbon is considered a mineral because it's not organic. But coal is organic. If you took my earth science class, you remember that coal is made from what used to be dead plant material that have died and smushed way underground until it becomes coal. So coal is organic, so it is not considered a mineral because it's made of something that was once living. Does that make sense? So another rule for something to be a mineral is that it has to have a definite chemical composition. What that means is that it's made of just one ingredient. And we'll come back to this later today in your activity. But for example, this sedimentary rock that I brought in, I don't know what it's made of, but it could be made of lots of different ingredients. There could be some iron in here, there could be some clay in here. I don't know what all goes in here. But I have a couple minerals here that I know are made of just one thing. So this is graphite. This is what your pencil lead is made of. Pencil lead actually used to be made of the metal lead, but that's poisonous, so they changed it to graphite. Graphite is made of just carbon. So there's no other elements in here but carbon. And this is halite. Halite is made of just a one molecule sodium chloride. So sodium chloride is also the same stuff your table salt's made of. So again, not a mineral because it's made of multiple things, but mineral because it's made of just one thing. And so one important thing to know is that these are both rocks. So all minerals are rocks, but not all rocks are minerals, if that makes sense. I forgot why I put some of these slides in here. It's been a while. So this is a rock formation. It's made entirely of hematite. Hematite is another way of saying rust. So this entire thing is just a bunch of iron that is rusted over time. So the entire landscape here is coated by one mineral called hematite. Again, hematite is made of just one thing, and that's iron oxide. Okay, so the last thing to be a mineral. So if a rock is inorganic, if it's naturally occurring, if it's made of one thing, it still has to pass one last test, and that is crystalline structure. So a rock must have a crystalline structure to be considered a mineral. So for example, this is halite. I showed you that. It was from up here. Here's a close-up image of halite. What shape would you say that this is? It's kind of like has cubes, right? If you ever have the chance, go home, find like a very dark surface and pour some salt out. And then if you have magnifying glass or something, look up close, but look at your salts really up close. Salts are made of tiny grains of cubes. Because halite, that's the same stuff as table salt. It's a mineral because it has a crystalline shape of cubes. So this little diagram shows you on the atomic level, that's because the sodiums and chlorides are arranged in cubes at this very smallest level. I think I have another example here. Here's another example. So quartz crystal is also a mineral because it has this crystalline shape. Instead of a cube shape, what kind of shape do you think this would be? How would you guys describe that picture on the left?
Like rectangular almost, like prism.
Yeah, prism. It's actually a six-sided shape. It's hard to know without actually being able to turn it in your hands. But it has a crystal six-sided shape. And actually, ice has the same kind of structure. And it's not always easy to tell if something has a crystalline structure. Sometimes you have to look at it really close. You might need a microscope to tell if it's a crystal or not. But like, for example, this graphite, you wouldn't be able to tell that it has a crystal structure unless you had a really strong microscope to find the crystal structure. Speaking of crystal structure, I just thought this was cool. This is actually some of the largest crystals that we found. It's deep underground, it's 1,000 feet deep in the Naica mine, that's in Mexico. It's very warm down there, which is why that guy looks so sweaty. 150 degrees, but that's just some of the biggest crystals. Those are gypsum crystals. Mm-hmm. Naturally formed crystals, yes.
They look like selenite.
Looks like what? Selenite. Okay, so based on what we've gone over so far, let's just see how you guys do on these quick little quizzes here. So we have quartz and we have breccia. Which of those two do you think is a mineral? Why the quartz? Sorry, say it again. Yeah, it's only made of one material. Well, how could you tell just by looking at the pictures? It's just made of one material. Yeah, just look at the color of the rock on the right. There's so many different colors in there that is probably the chances are high that breccia is made of more than just one thing. Quartz, remember, minerals are made of just one pure substance. So the breccia is not pure. It might have minerals inside of it. Well, I mean, it does have minerals inside of it, but it's not one consistent mineral. Here's another one. Got line. This one's a little bit tricky. Why ice? So they're both solid, but why else? Yeah. Well, so that, but it doesn't matter what it used to be, is what it is right now. So this one is not as obvious. Limestone forms through precipitation. You guys might remember that word. When lots of dead animal material and other material precipitates. So limestone usually contains some sort of fossil. So again, fossils are organic material, so that would not be considered a mineral. So ice is the mineral because it's naturally occurring. There's ice everywhere. It has a, what was the next one? Made of one pure substance, and it does have a crystalline structure. If you ever see snowflakes, you know that those are six-sided structures. Limestone is not, because it usually contains some sort of organic material, which what I was talking about, the fossils. I think that's the end. Okay. So that's minerals. You guys have any questions over that? Okay, I'm gonna stop the recording for this next part.